Hello everyone, and welcome to Atmos International's discussion on improvements in leak and theft detection technology. I am Harry Smith, and I am a sales and senior research engineer, and I'll be the person over the next 20 to 30 minutes discussing the improvements that we have made to our leak and theft detection technology. The agenda of today's talk will be on the introduction to Atmos International. We'll then move on to Atmos leak detection solutions, the improvements to our leak detection technologies, and finally I'll end on the success stories we've had utilising Atmos technology around the world. So who is Atmos International? Well, we are a pipeline technology company, and we were founded in 1995, and over the last 25 years we've pioneered advanced technology to support the pipeline operations in oil, gas, chemical, water, aviation and the mining industries. And we primarily concentrate on two areas, and that is leak and theft detection and simulation technology. As I stated before, we've been in business in just over 24 successful years, and we have our 25th birthday this year. We support more than 215 clients in 60 countries, and our technology has been installed now on more than 1,500 pipelines worldwide. We have a portfolio of 18 software and 10 hardware products, in which you'll see some of those today. And we have a team of over 180 dedicated professionals worldwide, and this is continually growing. We're an independent company, and we continuously invest a proportion of our profits into research and development. So what does Atmos International do? Well, here is a slide of all our software and hardware products. We have an array of different leak detection technologies. We have an array of different theft detection technologies, simulation and operation management tools such as pig tracking, batch tracking. Today's talk will concentrate on our Atmos Pipe LDS and our Atmos Waveflow LDS. Just a bit of a background into Atmos International. Our head office and head of research is found in Manchester, in a town called Disbury. We have a China office, we have two main offices in the US in San Antonio and Anaheim, and we have an office in Costa Rica. The two offices in the US support operations in North America and Canada. San Jose supports projects in Latin and South America, as well as providing maintenance for our American projects. We have a China office, and the UK office supports the rest of the world. And we also have agents dotted around the world for support in different countries. Atmos Pipe is a statistical volume balanced leak detection system, and it was primarily developed as a software-based LDS. It would utilize SCADA data and existing instrumentation on the pipeline to provide a reliable flow and pressure analysis. It can identify operational changes automatically and detect leaks during transient, dynamic and static conditions. It is fully compliant with the API 1130 and TRFL. It's been field proven for well over 20 years on hundreds of installations of varying pipeline lengths, varying diameters and varying complexities. So we can do multiple inlets, multiple outlets, short pipelines, single in and outs, oil, gas, multi-product. It can detect leaks under all operational conditions with minimal false alarms, and it has a high level of sensitivity. It provides an array of system outputs from leak alarm, leak location and rate, daily station information, watchdogs via OPC, leak time and volume lost. And all this information can be presented in a graphical user interface, and we are moving into a new HMI as well. Our second leak detection system is what we call Waveflow. Atmos Waveflow was developed as it was seen during research over the years, and more importantly research performed by the API, that combining different leak detection methods provides you with an overall more reliable system, as it offsets the weaknesses of a single method. So Atmos Waveflow combines primarily 4 leak detection techniques. It combines a negative pressure wave. So when a leak or theft event occurs, it generates a negative pressure wave that propagates in both directions along the pipeline. And as long as you have pressure sensors and data acquisition units to pick up that signal, you can very accurately pinpoint the origin of that leak. This is combined with an intelligent flow balance, very similar to the Atmos Pipe system and what a lot of leak detection methods are based on. So it identifies small discrepancies between the inlet and outlet flow to detect new and existing leaks. As well as those two methods, we combine pressure distribution analysis. So if we can have multiple pressure sensors distributed along the pipeline, we can do cross-checking analysis. The advantage of having multiple pressure sensors means we can shorten the distance in which a pressure wave has to travel, and we shorten the distance in which the LDS system has to handle. This means we can have improved reliability, improved response time, improved leak location. We also combine this with dynamic model analysis. This is slightly different to Atmos Pipe. Atmos Pipe is using probability to determine if the operation it's seeing is a genuine leak event or it's something that's naturally occurred in the pipeline. What Waveflow utilizes is pattern recognition. When a leak occurs, it generates a very unique pattern with how the pressures and flows change. When the leak detection system sees this, it will alarm very, very quickly. Utilizing pattern recognition means we can detect leaks in minutes rather than tens of minutes. So Atmos Waveflow, as I said, combines 4 methods, but combines 2 primary ones. It combines a negative pressure wave and an intelligent flow balance, and this gives us the following advantages. It allows us to detect and locate leaks and theft points. It's highly sensitive, very accurate leak location, and very fast response time. But a negative pressure wave is only an onset detection method, meaning it can't detect any existing leaks, and it does have difficulties detecting very slow opening leaks. This is why we combine this method with the intelligent flow balance. This is able to detect new and existing leaks, detect slow forming leaks, and the same as Atmos Pipe, is able to perform under all operational scenarios. It monitors for mass and flow imbalance, much like Atmos Pipe, and it also utilizes elements of RTTM for inventory correction and draining and filling. The negative pressure wave, as I stated before, it monitors pressure events at each end of the pipeline and alarms on timed events that come from a monitored section. And as I stated in the previous slide, the advantages that this has is it's very good for theft detection. It can provide very accurate location, which is critical in pinpointing a leak or a theft point, especially when we're talking about theft, because the thieves will try and hide their activity. It has very good sensitivity, generally less than 1%, and in some cases less than 0.5%. Here is just a simple demonstration of how the negative pressure principle works. So a leak is generated, and as you can see, the pressure waves propagate along the pipeline and will hit a pressure sensor. Depending on which pressure sensor falls, that gives us an initial indication of where the leak is on the pipeline. As you can see here, the inlet pressure transmitter has fallen first. This gives us an indication that the leak is closer to the inlet sensor because the outlet sensor falls later on. So how do we get such accurate leak location? How are we so sensitive when we're utilizing Atmos Waveflow? Well, we do this by combining software with our own hardware, and we utilize a unit called the AWAS unit. And this is a very simple data acquisition unit that allows us to sample data at a high rate, around 60 samples a second. We can take 4 to 20 inputs from flow meters, pressure transmitters, and temperature sensors. Then that analog signal is digitalized, sent to servers or a cloud, and then the data analysis is performed within our software. There is no filtering or anything applied in these AWAS units. It's purely digitalized into a digital file and sent to our software, where then we can do the analysis we require. It's GPS time stamped, which means we know exactly to a very specific time when each event occurred, which is again important for leak location. It's got dual redundancy for communication. We can work with an array of communication from VSAT, 3G, 4G, fiber optic, radio link, and TCP/IP compatible. It can work in extreme temperatures from -40 to +80. And also when we have a communication failure, it has built-in flash memory, and it can store 4.5 hours of local data. Once that communication is re-established, the data will be pushed back and reanalyzed. It has a simple diagnostic array of LEDs for maintenance purposes, and our AWAS 4 unit can connect directly to ultrasonic flow meter heads if required. So as I stated before in a couple of slides before, our flow balance system reduces the uncertainty to improve leak response time by using pattern recognition. And as stated before, it's very reliable in detecting existing leaks, continuous leaks, or slow forming leaks. And a flow balance system, very much as the Atmos Pipe system can, it can work in all scenarios, from transients to dynamic to static. The negative pressure wave, depending on the change in pressure, can have some difficulties in transient conditions. Here is an example of our flow balance screen. As you can see here, this is a leak that's been generated, and you can see that there's a clear increase in flow at the inlet and a decrease in flow at the outlet. And our flow difference has picked that up. And the bottom screen you can see here with the green bar is showing normal operational conditions. And as the flow difference starts to change, it goes into pre-alarm and then into alarm. And then once the leak closes, the system begins to fall and the system goes back into normal operations. And it's this type of pattern matched with pressure falling at the inlet and outlet that the system is looking for. So I've given you an overview of our Atmos Pipe technology and our Atmos Waveflow technology, but what are the improvements that we have made to these leak detection systems? Well, I don't know how much you know about leak detection systems, but there's a number of papers out there that discuss the advantages and disadvantages that each method has. One of the biggest disadvantages a flow balance system had was that because it's utilizing SCADA rate data, and that could be at 1 second, 5 seconds, 15 seconds, it limits the leak location accuracy that you can provide, meaning the best case scenario for most flow balance technology would be ±1 kilometer. If you're doing theft detection with that, or even leak detection with that, that isn't good enough. So, and as well as this, we have the issue with the negative pressure wave that has challenges with transient conditions, and it also has challenges with reliability, as it can in some scenarios generate false positives. So what has Atmos done? Well, we've looked at the challenges that we're facing on pipelines, and we're facing with providing reliable, sensitive and accurate leak detection systems. We come across the following problems. We come across lack of communication on the pipeline, lack of power, lack of instrumentation, lack of housing for our equipment, and also we have the issue of trying to improve leak detection performance on these pipelines. So how do we get around improving sensitivity, response time and leak location accuracy? Well, firstly, to improve our flow balance systems, we've integrated what we call our fast scanning module. So this fast scanning module makes leak location more precise, allowing leak location as accurate as ±100 meters. This means we can take our flow balance systems that were historically best case scenario ±1 kilometer and dramatically reduce that. So how has Atmos done that? Well, we do that 2 ways. Option 1, we utilize our own data acquisition units. That means Atmos Pipe has gone from being purely a software-based leak detection system to be integrating hardware elements to improve its performance. So what we will do is we'll read pressure at a higher data acquisition rate, and if we can, we'll also read the flow data. Another method is to connect to SCADA systems that support historical reading using OPC UA. And this will allow us to take that data when required and rerun it at a higher rate. So what we're saying is that the systems will still perform at the normal SCADA rate data that we're collecting, but when a leak event happens, the systems will request that data again at a higher acquisition rate. So the system will request a section of data, and that section of data will be reprocessed at a higher acquisition rate, allowing us to dramatically improve our leak location. Here is an example of it at work. Atmos Pipe is currently being installed on a pipeline in Latin America where it suffers from severe theft problems. And this system is utilised in fast scanning. So Atmos Pipe alarmed on a suspected theft event, and the fast scanning module was initialized, and an improved leak location was provided of 9.280 kilometers. This was provided to the customers. They went out to the pipeline and located the theft at 9.210 kilometers. So that's an inaccuracy of plus 70 meters. If fast scanning wasn't being used and we were using the standard SCADA rate of this pipeline of 5 seconds, we would have provided a leak location of 11.3 kilometers, which is an error of 2 kilometers. By utilizing this new module with hardware that allows us to sample at higher acquisition rate, we were able to improve the leak location error from 4% to just 0.125% of the section length. And to give you an idea of what this pipeline was, this section of pipeline was a single inlet and outlet. It was 56 kilometers long, multi-product, and as I stated before, it suffers from theft event. So this just shows you that a historical disadvantage of flow balance has been dramatically improved to almost the level of a negative pressure wave system. The next thing that Atmos has developed is what we call the Eclipse unit. And Atmos has developed this as a means of being able to provide instrumentation into locations and onto pipelines that previously wasn't possible. The Eclipse is a completely non-intrusive hardware solution that allows Atmos to install non-intrusive pressure, flow, temperature onto pipelines from diameters from 4-inch to 30-inch, and it will work on painted lines, not wrapped lines, but painted lines. It combines all the onboard processing and communication options that we require. So this Eclipse unit can work with 4G, radio link, VSAT, TCP/IP, and it contains all the data acquisition we require inside the box. And this Eclipse unit, as you can see here, attached to real pipelines around the world, it's also ATEX certified Zone 1. Of course, it uses non-intrusive pressure, which means it's not as accurate or as an intrusive PT, but we're still able to see pressure changes down to 10 to 15 millibar. So that's around 0.015 bar of change, meaning it's still sensitive enough to provide reliable leak detection and even theft detection. As well as it being ATEX Zone 1, it's IP68, and it's also passed its test to be buried. So this Eclipse unit, if you want to prevent it from being tampered with, can be buried to a depth of 2 meters. So this is just a sort of development timeline of the Eclipse unit. So as I stated before and a few slides ago, to improve our leak detection systems, especially within the Atmos Pipe and the Atmos Waveflow system, we've utilized what we call the AWAS unit. And this was developed back in 2010 to allow us to sample at a higher acquisition rate. In 2016, we tried an attempt at our first non-intrusive pressure that we called the Halo, as you can see here in this picture here. And then in 2018, we took the lessons learned from the AWAS unit and the Halo and combined it with non-intrusive flow and temperature, which we now call the Eclipse. We took the 60 Hz data acquisition and built-in communication and combined that into an ATEX 1 body. And we made sure that this Eclipse unit works with all our LDS systems, from Atmos Pipe to Atmos Wave to Atmos Waveflow. And in 2020, we're now looking at slightly more advancements on how to get even more performance out of the non-intrusive pressure. As I said, we've now got it certified to be buried, and we're working on it with alternative communication solutions as well. So what I wanted to show you here is pressure data from a non-intrusive Eclipse unit and pressure from an intrusive PT on the same pipeline. If we take the first screenshot in the top left, the pink is showing you the non-intrusive pressure, and the blue is showing you the intrusive PT. Now what I want to highlight here to you is the small change in pressure that is actually being detected. So this small operational change is actually equating to 0.3 bar of change. And as you can see in the top trend and in this middle trend, that both the non-intrusive pressure and intrusive pressure are coupled together and follow in a very, very similar pattern. Let's take a look at the second screenshot. Again, the red is the intrusive PT and the black is the non-intrusive PT. Now what I want to draw your eyes to is this very small change in pressure here. This equates to 0.1 bar, and again, both the non-intrusive pressure and the intrusive pressure sensor are coupled and follow a very similar pattern as the pipeline operates. Now, that was just operational data. What I wanted to show you here was data from an Eclipse sensor installed on a Belgian pipeline. These are real leak tests that the customer did to test the effectiveness of the non-intrusive pressure against an intrusive pressure transmitter. For this leak test, the section length was around 40 kilometers, and there was a non-intrusive Eclipse at the inlet and an intrusive PT at the outlet of this section. And the customer did a different array of leaks. They did from 1% down to 0.6. And as you can see here, as the leak is generated, it creates a negative pressure wave, and both the non-intrusive pressure and intrusive pressure sensor fall. The non-intrusive on this screen is in black and the intrusive is in pink. So this is demonstrating that even though it's not actually physically measuring the product, it's still able to provide very accurate sensitivity, and more importantly, it's still also able to provide very accurate leak location as well. As well as the Eclipse unit that allow us to connect to pipelines that previously didn't have instrumentation, and we no longer have to have the concern of asking for new tapping points, we've also developed what we call the JSP unit. And this is designed to remove the need for very expensive bespoke field cabinets, and all we do is take a cabinet that we need for leak detection purposes. So each AWAS JSP includes a flow correction processor to allow us to collect flow data from non-intrusive flow sensors, and it allows us to collect pressure and temperature from intrusive or non-intrusive sensors. The onboard communication is again the same as the Eclipse unit. Now, why would we use a JSP over an Eclipse? Well, the Eclipse unit can only work on up to a 30-inch diameter due to the length of its ATEX body. The ability to have a JSP means we can go on to much larger diameter pipelines, and also it can handle much more extreme conditions. For example, we can install this in very, very cold temperatures or very, very hot temperatures. It means that Atmos has assessed the challenges and it has combined different technologies to meet those ones. As well as the new fast scanning module and the new hardware solutions that Atmos has to offer, we've also developed a new theft module that we call Nano Wave. During the discussion, I said there was an advantage to having multiple pressure sensors along your pipeline. By doing that, you have the ability to be able to cross-check data, and you're able to see much smaller changes of pressure. This, in essence, is what the Nano Wave module is about. It was designed to improve theft detection in dynamic conditions, because thieves can open the valve very, very slowly in dynamic conditions, which creates a very small change in pressure, which can often be masked by the operations on that pipeline. So how does the Nano Wave module work? Well, it uses distributed sensors spaced every 3 to 30 kilometers, depending on the pipeline length. If you have a very, very short pipeline, for example, let's say 1 kilometer, then you would space them accordingly. From testing, we've been able to get theft detection down to 0.04% of the nominal flow. And we do this because we use longer filter lengths and cross-checking against all the pressure sensors along the pipeline. This module isn't interested in large leaks or ruptures. It's purely there to look for these slow openings of a potential theft event. It's also very good at detecting weeps as well, because weeps have a similar characteristic to thefts. The other advantage that we found that this Nano Wave module can use is in the multi-phase industry, where we have very challenging characteristics of the pipeline, and history has shown it's been very, very hard to provide leak detection on these types of pipelines. However, if we're able to put distributed pressure sensors along that section and adopt this Nano Wave module, we are able to provide reliable leak detection based on the negative pressure wave principle. So, for most of my talk so far, I've been talking about leak detection and theft detection. Now, there is another important element, and that's rupture. This came about during the discussions raised in the API 1175, and it talks, and the 1175 has a number of important principles that we should listen to. One, it talks about the continuous improvement and testing of leak detection systems that I've so far discussed with you, but more importantly, it discusses that we need to start treating a leak, a theft, and a rupture as three different characteristics, and make sure that our system can handle these three different scenarios. So as it stated, a rupture alarm is treated differently to a leak alarm. As conventional LDS search for small leaks as well as ruptures, there's an inherent uncertainty, instrumentation failure, hydraulic anomalies, the operator might operate the pipeline slightly differently, and it may cause false alarms or a false positive. And this can take time to confirm a leak before shutting down the pipeline. However, a rupture alarm is a very, very large loss of product, and when a rupture alarm appears from a system, it should trigger an immediate shutdown of the pipeline. A shutdown costs money, it's loss of revenue and emergency response time. So you need your rupture module to be very highly reliable and never miss a rupture. This is why Atmos has developed a separate module in its system. As I said, this is why Atmos has developed a separate module for detecting ruptures, and we utilize 4 algorithms to guarantee detection of all ruptures. So we use LOKL, inventory, DMA, and PDA. So LOKL allows us to detect ruptures that would be close to a pump station. Inventory allows us to detect ruptures when the pipeline goes into slack. DMA uses pattern recognition that we utilize across the whole pipeline area, and PDA's pressure distribution analysis, again across the whole pipeline. Combining these different detection methods assures that when a rupture does happen, regardless of where it happens on the pipeline, it's detected quickly, accurately, and reliably. So when the alarm comes in, because it's a separate module only interested in looking at large leaks, the operator has confidence that when he sees a rupture or she sees a rupture come in, the pipeline is shut down and the spill is mitigated. Here is just a table that I'll leave on for a few seconds to demonstrate the different types of scenarios that a rupture could happen and which one of the methods would be able to detect it. You'll be able to have a copy of these slides to review in your own time. And finally, another development is all about how the operator interacts with the leak detection systems and how that information is provided to them. So Atmos utilizes standard leak detection graphical user interfaces that has standard SCADA system screens, utilizes maps to provide the leak location. It has trends so that they can analyze an alarm or have the trends open so that they can monitor the pressure and flows in real time. One of the latest developments that Atmos has developed is what we call the Web GUI. This is an application that can be installed on any machine and accessed through an internet browser through a secure VPN. There's a number of advantages of doing this. It means that multiple users can have access to the leak detection system. Being through a secure VPN means it's very, very secure to IT cyber security. And more importantly, it provides bigger visibility and reduces the reliance on operators to interact with the LDS. We can also do it that if you had many pipelines, you can set different levels of user permissions. So one user could see all the pipelines, but maybe one operator is only interested in 5 pipelines. So we can customize the GUI to only show those 5 pipelines. It means that we can have standard LDS GUIs in the operator's room, and we can also have other members of staff accessing the same information through a web GUI. So before I move on to this next slide, what I've demonstrated to you is that Atmos has looked at weaknesses in the leak detection technology available and try to make dramatic improvements to it. So firstly, it's made improvements to a flow balance system by combining it with high acquisition rate hardware. We provided hardware solutions so that we can now install instrumentation where previously it wasn't possible, and to provide leak detection to pipelines where it might not have been previously possible through the use of JSPs and Eclipse units. We've provided a new theft detection model to improve the performance of theft detection in dynamic conditions. As we've all seen over the last few years, theft over the world has dramatically increased. We've also developed a separate rupture module because we've seen that we need to understand that a leak and theft and rupture is very differently, and we need to address those in slightly different ways. So finally, after talking about our technology, where has our systems had success? Well, firstly, pipeline in Romania. We successfully won this following a competitive leak trial. We were given 1 week to install our equipment and to tune, and then we had 1 week of blind leak tests. This pipeline is a crude 10-inch and it covers a 250 kilometer pipeline network with multiple inlets and multiple outlets. It utilizes Atmos Waveflow for leak and theft detection. This system was heavily tested by the customer to build confidence and trust that the system we were providing would provide reliable leak and theft detection system. Over 288 official leak withdrawals were performed and 19 unreported. This means that the customer went and did leaks without informing Atmos first, and the system detected that. The sensitivity currently of the system can detect a 4mm hole size and leak location of less than 200 meters, while more importantly, having very low false alarms. We've had massive success in detecting and locating thefts all around the world. In the UK, our systems, both Atmos Pipe and Waveflow, have been used to detect 30 tapping points since 2014. In Costa Rica, our combined Atmos Wave and Atmos Pipe with fast scanning has detected 500 and counting since 2017. In Costa Rica alone, we detect on average more than 40 tapping points a month. Italy, we've found 4 tapping points since 2016. Romania, we've found 4 tapping points since 2019, and this was while commissioning the system. Turkey, 20 tapping points since 2014, though this could be higher. And in Indonesia, we helped dramatically reduce their theft problem on a section of pipeline from over 700 tapping points to less than 10 tapping points in 2018. The Indonesian example is a good analogy of combining multiple technologies. So they combined line walks with security teams, with drones, with inline leak detection system such as Atmos Wave, and the combining of different methods all together ultimately dramatically reduced the impact of tapping points. I think this is important to show you because previously theft used to be known as very isolated to certain regions, maybe Iraq, Nigeria, Russia, and parts of South America. However, over the last few years, this has seen a dramatic increase around Europe and specifically the UK. And I wanted to show you that in 2014, a pipeline operator came to Atmos and requested that we install our system and see if they are suffering from product loss. On that company alone, in that year, we found 5. Following that suit, a number of other UK operators requested the same technology. Again, in 2015, we started to uncover multiple tapping points that had been going under the radar of these pipeline operators. And slowly but surely, because we have high sensitivity, high response time, and leak location accuracy, these tapping points were being found quickly, and more importantly, thieves were being caught and equipment was being confiscated. And over the years, we've seen a dramatic reduction to now on average about 1 a year. And I thought finally, to just the last few slides, is just to end with a few examples, a few pictures of the different types of tapping points that our system has detected, and more importantly, the different types of techniques that we're actually dealing with. So as you can see here, the top left here, this unfortunately is a failed tap. This isn't water spraying out, this is jet fuel. Two types of tapping points here, all different types of array of equipment. And you've got ones from Europe, ones from South and Central America. I don't know why they do this, but often when there's a tapping point failure in Latin America, they wrap a t-shirt around it. Anyway, I don't know what that's meant to achieve. This is an interesting one. This is the one in the UK that our system found. So this line in blue is the pipeline, and this line is red is the hose route that the thieves laid. This is 1.5 kilometers worth of hose, around about £30,000 worth of hydraulic hose they laid. I don't know if they paid that. And this was an abandoned farm. They opened the tap once and we were able to locate it. The thieves had even tried to use dead animals and bury the hose to try and throw the scent off the sniffer dogs, because sometimes operators use sniffer dogs to try and find the tapping point. So it was a very sophisticated operation to lay this, but unfortunately they weren't able to use it as much as they want, I don't believe. Again, here we go, different tapping points. This is on a huge 42-inch crude pipeline, double tap on a multi-product line, all different techniques, all detected and located utilizing Atmos technology of either Atmos Pipe or Atmos Waveflow. Thank you very much for listening. Again, I've been Harry Smith. If you have any questions, please contact us at commercial@atmosi.com, or please contact our number. We look forward to having any questions sent to us, and I'll be more than happy to answer them. As I stated before, these slides are available via the PTC website, and they'll be able to download it for you to review in your own time. Thank you very much for listening. I hope you enjoyed it. Bye-bye.